So now that we finished learning targets 1 and 2, which introduced us to exponential functions, and we learned about all the different parts of an exponential function and how to write them, now we're going to start looking at graphs of exponential functions. Part 1, we are going to identify the solution set, and we are going to write functions to model a graph. So remember that the graph of a function is really just the combination of all of the ordered pairs that make the function true. So for example, the graph is really just saying that in whatever equation represents this, these are all of the xy pairs that are going to be okay to plug into that function and still make it a true function. These are just the ordered pairs that satisfy the function. And the graph is just the combination of all of them. So let's look at this graph. Whatever function this is, we can tell if the point 1, 2 is a part of the solution set of the function or not. So whatever function represents this, let's just say right now, because we don't know what equals, we don't know what a and b are, this function, if we were to plug in 1 for x and 2 for y, or f of x, would this be a true function? Or would that be a true statement, a true equation? So let's look. The point 1, 2 is on the graph, which means that it is a part of the function solution set. If we look at the point 2, 4, that's 1, 2, 1, 2, 3, 4, also on the graph, which means that is also part of the solution set. The point 1, 6, so 1, 2, 3, 4, 5, 6 is not on the graph. That means that this xy pair, if we were to plug it in here, we would get two sides that don't equal to each other. So this is not part of the solution set. And then the point 3, 8, is that part of the solution set? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Yes, it is, because it's on the graph. And now the second part of this part of the learning target is to not only identify the solution set using the graph and tell whether or not an ordered pair is part of the solution set or not, but also to write a function to model the graph. So to write a function, we need to recognize what the value of a is, which is the y-intercept. So that is 0, 1, which means a equals 1. The value of b, we can just list all these ordered pairs. 1, 2, 2, 4, 3, 8. And then we can find b by going through and finding the multiplier. So 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by 4 is 2. So there is a common multiplier of 2, which means that b equals 2. And then lastly, once we can look at the graph and identify a, and then b is how it's changing, we can use those to write an actual function that models the graph. And that is part 1 of learning target 3. Deciding whether or not an ordered pair is part of the solution set, and then writing a function from the graph by identifying a and b by turning the points on the graph into a table.